Ruben, let's talk AI, capital markets in particular, or I say Gen AI in particular, and capital markets. Share, please, a little about yourself and your role at AWS today.
Sure. So I'm part of the market development team for capital markets, and I cover also financial services more generally. So we are a team of folks that come from the business, right? So my background is I ran businesses at S&P Global. I was an investment banker at UBS originally. And we have a team of folks like myself who can relate to sort of the business problems, the business value that we can help our customers create. And specifically with generative AI, I took over the machine learning practice about 2 years ago, and then the Gen AI, ChatGPT wave hit, and now I've spent most of the last 2 years really talking to customers and our sales folks and conferences like this, talking about Gen AI and learning about what customers are doing in the Gen AI space.
Excellent. So I know what everyone's thinking out there. Is Gen AI going to replace the loan officer? Is that where we're going in capital markets?
I don't think so. I mean, I think I think Gen AI in many cases, in financial services in particular, is a productivity tool, right? Because direct to customer use cases in financial services are sort of off the table, right? You have fiduciary responsibilities as a financial institution, and if the liability is significant, right? So the model goes out and tells the customer something wrong, or something that the customer acts on to lose the money. Nobody wants to be in that situation. Yeah. So, which is different actually from Amazon.com, where in the retail business we're perfectly happy exposing large language model results straight to the retail customer, right? So if you go on Amazon.com today and you read a review summary of a product, what we've done is we've taken an open source model, customized it just for the purpose of writing review summaries, trained on all our reviews, and that then generates, based on the latest reviews, generates a summary that customers can read, and that's how you read the summaries on Amazon.com today. So retail is very different, but certainly in financial services, most of it is human in the loop and making humans more productive, saving money, potentially also new product development. Particularly in the hedge fund space, now you can access unstructured data and extract signals for your models in a way that just wasn't possible before. So yes, lots of use cases, but none of them are the model is not making the decision.
Not replacing the people just yet. For all the points you just made. In our business, we're fortunate to have a number of financial services customers working with us on their Gen AI. We've seen use cases like leveraging Gen AI to improve the efficiency and scalability of like financial advisors, right? Making it easier for them to more quickly ascertain findings out of the mountains of data that is out there on a market. I'm curious, in your role, what are some of the more, you talked about driving more efficiency with their employees or productivity with their employees. What, maybe can you go a layer deeper? What are some?
Yeah, I mean, I'll say that there's sort of 4 or 5 use case categories that we see over and over again, right? One is customer service, including sort of call center technology, much of which actually existed already with sort of more traditional NLP solutions, right? So call centers would generate transcripts of conversations. With traditional technology, those conversation transcripts would then generate queries against a knowledge base. The knowledge base article would come up for the call center rep to convey to the customer during the call, after the call. The problem, of course, was without generative AI, you had this knowledge base article that was relevant, but you couldn't consume it, and so you'd have to sort of send it on after the call. But now with generative AI, you can get near real-time summarization of knowledge center articles that are brought up, in sort of response to the real-time conversation. And so they explained to me it's like playing chess with Kasparov whispering in your ear. And so lots of call center, customer service type use cases, also pre-call summarization, right? So summarizing all the interactions with the customer before you get on the call, and then post-call analytics, right? So we have lots of customers like Rocket Mortgage, JPMC, and others that have millions of calls a year with their customers, and they were never really able to analyze the sort of the full volume of calls before until now. So in the past they would sample them, but now what they do is they do topic modeling of all the calls, and so they're able to take 1 million calls, categorize them into, say, 10, 20 topics, associate sentiment with each of those topics, associate other metrics like, issue resolution, length of calls, sentiment associated with calls, etc. So now for the first time, they can actually analyze that volume of customer interactions, and they can, improve operations in response. So that's another one. I talked about data extraction from unstructured text, right? That actually, again, was a traditional solution, tended to be built on OCR, an OCR layer with a bunch of rules on top, right? So you could actually, have a loan application, and with those traditional solutions, you'd be able to extract the relevant data out of the loan application and present that to the underwriting officer without then necessarily having to go through all the documents. The problem with those legacy solutions, though, is that they were very fickle, right? Because you would have this set of rules that, as a developer or as a business analyst, you'd have to build, and then if the underlying document format changed a little bit, the system would break, or if you added a rule for a new data item, you'd break two other rules, right? Whereas now with large language models, all that logic is in the model, right? So you can essentially give the model the document, ask it for the data items you want to extract, and that's sort of it, more or less, right? So that also means that these systems now are much easier to build, they're much easier to maintain, they're self-healing, right? So at hedge funds, they tended to have big teams who were just working on the web scrapers, because the web scrapers would break and break and break, but they needed them running all the time.
Yeah.
Now with large language models, they're much more self-healing and robust to changes in the web information. And then there are use cases, just related to, like, as you said, the financial advisors, like knowledge workers more generally, right? We're all knowledge workers. We all go and we find information in a document, we extract it, we summarize it, and we develop our thesis, right? And that's the same for paralegals, same for investment analysts, same for salespeople responding to RFQs, RFPs, right? So all those knowledge worker roles are increasingly changing to being one of checking for accuracy, checking for completeness, and then driving your thesis without having to go and find all the details in all the underlying information. That's very powerful. It applies to a lot of different situations. And then there's also this final use case that's brand new, which is this idea of natural language interfacing to analytics, or democratizing access to analytics, for business users, right? So a business user can now, without having to write a query, without having to write code, they can ask questions like, graph me up the performance of this portfolio or something like that. And then that natural language query is translated into code or SQL query. The data is returned, is visualized, is brought back, and Bridgewater has a solution in this space. And interestingly, with Bridgewater, they're saying, we think we now have a GenAI solution that is at par with a first-year analyst.
Wow.
We don't think it'll do the job of a mid-level or senior analyst anytime soon. But now we have to think about our business in the context of, we could have 1,000 first-year analysts. Like, what does that do to how we approach our business? Because it's not like they can necessarily save money with that, because they need the second-year analyst, and so they still have to hire the first-year analyst, right? So some of the ROI calculations sometimes are a little tricky. But yeah, definitely that democratizing access to analytics. We have other use cases too, where the CFO and the CEO can now go and ask those questions directly of the data without having to have a dashboard author or query writer in the middle. So I would say those are some of the big ones. Obviously, developer productivity, I think it was talked about earlier, right? That's a big one. I don't focus too much on that. It's because it's an easier one. It's sort of self-evident. Even at Amazon, we have just the upgrading process from like Java 7 to 11 to 18 or wherever the latest ones are. That process for us has saved us about 100,000 hours, which translates into millions of dollars a year in just being able to do upgrades more easily. And it's an easy use case because it still goes through code reviews, right? So the risks aren't the same maybe as with sort of non-code type solutions. So that's obviously a big one too.
I think like unit testing is another one, right? Where you can leverage GenAI today, quickly write your unit tests.
Right. Yeah, unit testing, upgrading, all of it. Yeah.
That's interesting with the entry-level analysts, financial analysts. Do they also see it making their more senior analysts more productive?
Well, I think they haven't really figured that. I think in some cases, yes, but maybe not with that particular example. I know there are solutions out there where, and those were sort of around already, like the Alpha Sense of the world, like boosted AI, these solutions that allowed investment analysts to access information from a very diverse set of sources that maybe they wouldn't even bother looking at in the past, right? So trade journals and boosted AI, they have sort of a platform for searching these sort of more esoteric data sources. And they said that they figured out before anyone else that Apple was shifting their supply chain out of China because they had picked up something in a trade journal in China or in APAC that sort of pointed to that, right? So this idea of, so the answer is yes, maybe not so much in terms of just pure productivity of first-year analysts, but in terms of being able to access information, particularly unstructured information, that was just inaccessible before because of the volume of it and the sort of disperseness of it.
Yeah. Interesting. Curious also, when I first joined Redis and was getting into more of the Gen AI use cases with our customers, it was pretty much right after ChatGPT came out, and it seemed like there was a lot of top-down mandates, right?
But
we need to do Gen AI, and there wasn't a whole lot more beyond that. People needed kind of pushing a lot of money in that direction, but not so clear as to what they actually want to do in their business. We saw a lot of prototyping going on. We're starting to move past that. Curious, similar kind of journey you're seeing, and in particular, as you see customers move from POC into production, like what does that journey look like?
Yeah, I mean, again, we have lots of good examples of where very large customers have been able to sort of complete that journey and put meaningful solutions into production, generate the cost savings, or generate the sort of enhanced customer experience. But there's a lot of, I think, more mid-sized type customers where the skill set isn't necessarily there and the experience isn't necessarily there, right? So they start with a POC. Typically, that means you take a very large model, do minimum of prompt engineering, minimum of data engineering. You get to, say, 75% accuracy, and that's good enough for a POC. You've sort of shown value or potential, right? But now, how do you get from 75% accuracy to high 90s, which you typically need for financial services? How do you get the latency down to something that's actually user-friendly? I mean, Redis has good sort of solutions in that area of low latency, high performance databases, but also how do you get the cost down, right? Typically, these very large models are good for prototyping, but they are high latency, high cost. So now the work you have to do is it's just an area that there isn't much experience in, right? It's things like RAG optimization, right? Some of which was discussed earlier. Semantic search, maybe combine it with more traditional search to do hybrid search. Also, more recently, this idea of graph RAG has become quite interesting, right? So the idea is that you take the results of semantic search and you then transpose those results onto a graph database, and then you traverse the graph as a way of finding the most relevant search results. And maybe there's also something in the graph that's sort of connected to everything the search brought back, but wasn't in the search, that could also be brought back as a search result. So graph RAG. So lots of search optimization, chunking strategies, embeddings algorithms, right? We see customers that are actually fine-tuning their own embeddings algorithms so that proximity calculation becomes relevant to the way they view proximity or similarity, semantic similarity. Right, so lots of stuff there. And again, that's sort of work in progress, right? And some organizations, they have the sort of wherewithal to do it, some not yet, although I think everybody will get there eventually. There's also this idea of, how do you make your data relevant, not only in terms of RAG, but also in terms of either fine-tuning a model for something very task-specific, or if you have a lot of examples of similar questions with the ground truth answers, you can provide those into the context window as sort of a multi-shot prompt approach, right? So not only are you asking the questions, but you're also providing examples of similar questions with the correct answers as a way of making the model much more efficient, using the context window much more efficiently. But then that means, you need to have the data engineering that actually allows for that sort of you can almost call it fine-tuning on the fly. So lots of challenges, lots of opportunities. Chain of thought is another one, right, where you can specify either in the model what sort of chain of thought process you want the model to follow to answer a specific question, or you can have it outside of the model as part of what was mentioned earlier, like an agentic workflow that follows a particular way of reasoning about how to answer a question. And Bridgewater actually has this for their unstructured data solution, that they have a chain of thought template that you can supply in addition to the question, so that the system knows how Bridgewater wants to think about reasoning about that problem.
Yeah.
So lots of stuff that needs to get done to get these models into production at a high degree of quality and efficiency. And that a lot of this is still work in progress. And frankly, it's nothing to do with the models itself, right? It's not like GPT-5 or 6 or 7 is going to solve any of what I just talked about, right? These are all problems that relate to how you bring your own data into the model and make sure you have the accuracy required. And so
Yeah, meeting that higher bar of accuracy, managing it at scale, evolving it longer term with cost in mind, all elements that critically demand for the fastest vector database and semantic searching in the industry.
Right, absolutely. No, absolutely.
But actually, I'm curious, and some of the things you touched on there, RAG, building your own model, training your own model. How does one figure out the right approach, or better yet, how can the two even complement each other? What's your advice to customers on how to think about that?
Well, so I mean, I think they often coexist, right? So again, going back to the Amazon.com example, right? The review summarization solution is a fine-tuned open source models on reviews, right? But then obviously we don't fine-tune it every day or every hour as new reviews come in, right? So we then use a RAG approach for the purpose of bringing in all the relevant reviews for the summary that needs to get generated in sort of more real time, right? Yeah. So often the two complement each other. I would say where fine-tuning, it has the sort of the biggest bang for the buck is when you're looking at sort of very task-specific solutions, right? Review summarization is a good idea. Like all it does is summarize reviews. It's very good at that, not good at anything else. Also, in some cases where the domain of the problem is very different from the domain of, sort of the common man's English that the models have typically been trained on, right? So, for instance, we have a customer, they do data extraction, term extraction from structured product term sheets. And structured product term sheets are just these very sort of specific type of documents that, fall outside of what large language models have been trained on and understand. And so for that purpose, you really do need to fine-tune a model and give it examples of, this is the structured product term sheet. These are the terms I want extracted, and train it on being able to do that for an unseen document. You're not going to get an off-the-shelf model to be able to do that right off the bat, right? But then more general questions, right, about sort of, say, extracting answers from annual reports or 10Ks or Qs and filings and analyst research and earnings call transcripts and news, right? All of that is, I mean, that's the same domain as the models have been trained in, right? So for that, you probably don't need to fine tune, but you need to have a lot of technology around the type of answer you want to get to, right? Because there's also different types of questions, right? The question might be, find me a specific fact in a specific document. Another question might be, give me some sort of thematic answer to a thematic question, like tell me what are the main risk factors in the tech sector, right? So that you have to approach completely differently, right? You have to now extract all the risk factors, the risk sections of all the tech companies, and then you have to do some cluster analysis, topic modeling essentially of what are the common risk factors, and then you have to summarize those clusters, right? So the answer is it's the techniques for how you get to the accuracy and the right answers. It depends very much on the type of question, and it's not a one size fits all.
Yeah. Well, ultimately, training your own model makes a ton of sense for specialized language.
Right. And also because you can train a relatively small model, right? So now you get something that's very cheap, very low latency, and very good at this one particular thing. And again, it goes back to this agentic type workflow, right? That you have different models that specialize in different types of questions, and then you have an orchestration layer that sends the question to the right model or the
Do
right
semantic routing,
right.
right?
The
So
semantic
instead of
routing, right.
one giant model for everything, you
Right.
may have multiple
Exactly.
models, do semantic routing, and then leverage RAG for the more current real-time data that's
Right.
coming into
Right. Right.
that
Right. Right.
environment.
Right. Exactly.
Yeah,
Exactly.
interesting. So it all definitely plays together. Maybe circling back to your experience in capital markets, curious your thoughts, or your experience. What do you see is unique to capital markets? You mentioned earlier heavily regulated. How does that come into play as your customers think through how they're going to use Gen AI?
I think they all have existing model risk management processes, right? Particularly, the big broker dealers. They're very heavily regulated. Everything they put into production with respect to machine learning goes through a model risk management process, goes to a model risk management committee. There are set sort of steps for what, as a data scientist, a data science team, you have to bring to committee to get a new fraud model approved. Right, and that's well known. So actually, getting a new fraud model approved is not that hard because you know what to bring. You know what to bring in terms of, the evidence, the ongoing monitoring process, and so forth. Now, for Gen AI, so none of that really exists, right? So it's very hard to get these models or solutions, Gen AI solutions, through the model risk management process or committee because with every new solution, they essentially have to evolve their model risk management policies, and they're sort of doing that ad hoc. And so that does create a bottleneck. But I would say what's maybe even more important is to have maybe a higher level AI policy so that as an institution, you know whether something is likely to be a high risk solution, a high risk problem versus a low risk problem, right? So a lot of these productivity enhancement solutions. In many cases, our capital markets customers have come to the conclusion that they're actually not high risk. They don't need to go through model risk management because essentially it's still the human analyst that's making the decision at the end of the day. All we're doing is making it easier and faster and better.
And presumably these folks already have access. It's the data they already have access to.
They have access to, or maybe it's like this idea of maybe they can access new data that they could have had access to, but didn't have time to access.
Yeah, they can't scale across.
They can't
all that,
scale,
yeah.
but again, it's the same process, right? So I think that's almost the starting point is this AI policy that allows you to distinguish between low risk and high risk, and then maybe go after the low risk or low hanging fruit first, and then for the higher risk stuff, that's where the model risk management process needs to evolve. And it's also very different, right? Because in the past, as a data scientist, you would go in and say, "This is my model." Today, you go in and say, well, this is actually not mine. It's OpenAI's model, it's Anthropic's model. And so, you can't make the same assurances, right? So the model risk management committee is going to have to come to terms with this sort of new world where these models are actually coming from the outside.
Yeah, interesting. Yeah, that's great stuff. All right, so a little bit of fun. I think we're coming up on time. The media loves to prognosticate on where are we going in Gen AI. You always hear the headline of when is it going to replace people?
Right.
Maybe not so quickly in the banking sector.
Right.
But curious, as someone with a lot of experience in this, let's beyond the media hype.
Right.
What do you see as being the big discussions out there in terms of what is the next big problem we're going to have to solve in Gen AI and where may it go next?
Right. I mean, everybody talks about AGI and how are we going to get to AGI, and I have no idea, but there are sort of two schools of thought, right? One school of thought says that the bigger the models get, the more data you train them on, and maybe you have to have synthetic data as a way of expanding that training data set. And the bigger data centers you build, and by the way, now Amazon and lots of the other cloud providers, they're investing in nuclear, right? Because they need their own power source. So anyway, so the idea is you have bigger data centers, more GPUs, more power, more data, synthetic or otherwise. And then as you feed these models more data, even with existing technology, you get these kinks in the curve where emergent capabilities appear. And that's already happened, right? So it's like
almost like a flip of a switch.
A flip of the switch. Like at some point, you don't really know why, but at some point you feed it enough data, and that's the point at which the model learns how to code. And we've seen that several times, but that's the point at which the model can do some basic arithmetic. But not because you taught it, but just because you fed it more and more data, and these emergent properties appear, sort of a kink in the curve, right? So one school of thought is you keep just feeding it more data, and we're going to get AGI with existing technology. Another school of thought says, well, no, existing technology is not going to do it because large language models today, they are trained on an amount of data that would take a single human 150 years to read. But that same amount of data, if you take into account the higher bandwidth of vision, is only the amount of data that a 3-year-old would absorb until the age of 3. And so the idea is that to actually take advantage of all the data that exists, you need to develop these more sort of real-world models that are vision-based and where the model would be able to observe a falling object and deduce Newton's second law, and that's the direction we need to go, and that's how you're going to get it. So I don't know which way it is, and that technology doesn't exist.
Is the thinking literally vision? Like this is going to be a system that's using, it was a naive question, but using cameras to consume this data? Like how, what
Yeah, essentially vision as by way of cameras to consume all this data and then develop an understanding of the world, that world model with the sort of a human understanding of how the world works through vision. Because the bandwidth of vision is so much greater than the bandwidth of language.
So we'll just have like billions of 3-year-olds everywhere? Excellent. Good stuff. Well, Ruben, definitely appreciate you making the time for us today. Love the conversation. Maybe a round of applause for Ruben today.
Thank you. Thank you.
We did it. We made it to the end. Thank you so much for joining us. We hope you got a lot out of today. If you'd like to learn more, we encourage you to either connect with our speakers on LinkedIn, set up a meeting with the Redis team member at the link below, or both. And thanks so much. We look forward to seeing you next time, hopefully in person.